Long before the first ships left Europe in search of the Americas, and even before humanity understood the concept of latitude and longitude, billions of living creatures had already mastered the art of navigation on this planet. Flocks of migratory birds traveling from Africa to Siberia, from Alaska to New Zealand, crossed thousands of kilometers of ocean, storms, and ice, yet still return to the exact same nest, the same branch, the same crevice in stone. No compass, no sextant, no map, and yet they possess a natural navigation network whose precision still makes aerospace engineers envious. When humans invented GPS, we were merely imitating something nature had standardized millions of years earlier. The story of these primitive pilots is not just a biological marvel, it is an evolutionary map of spatial intelligence. In the mid-1950s, biologists in Germany conducted a series of unusual experiments. They placed indigo bunting sparrows inside an artificial planetarium. Beneath the dark dome, artificial stars rotated around the North Celestial Pole. As soon as the constellations began to move, the birds launched themselves toward a fixed direction, the same direction they followed during real migration in the wild. When scientists rotated the sky in reverse, the birds changed direction as well. This revealed an astonishing truth. Birds navigate through astronomy, not by memorizing individual stars, but by tracking the rotational center of the night sky, a world axis that humans only understood much later. Mechanically speaking, birds remember the angular rotation of constellations around a fixed point. Their brains do not store images like a camera. Instead, they function like motion angle sensors, recognizing rotational patterns rather than absolute positions. This means they do not merely see the sky, they perceive the structure of space itself. If humans studied astronomy to conquer the seas, birds mastered it to conquer the sky tens of millions of years before we built our first sextant. When clouds cover the sky and stars disappear, these winged pilots still do not lose their way. Studies of homing pigeons show that when released in unfamiliar territory, they do not fly straight home. Instead, they curve along highways, rivers, and valleys. In the 1970s, researchers in London attached miniature tracking devices to pigeons, and the results astonished the scientific community. Their flight paths almost perfectly overlapped with human-made infrastructure, railways, highways, and even the banks of the River Thames. It turns out pigeons do more than sense magnetic fields. They also read terrain through modeled vision, recognizing familiar structural patterns across landscapes. To them, a winding river is not just water.
Good, I'm picking up the signal now.
It is an energy
pathway.
Let's
release him.
A data corridor stored in the brain. If stars provide global coordinates, terrain acts as a local addressing system, allowing birds to merge sky maps and land maps into a synchronized network. Through this integration, birds can effectively log into Earth itself. Navigating through a spatial system, humanity has only recently begun to digitize. Over the open ocean, where sky and water blur into one horizon, even light cues can become meaningless. Yet seabirds, albatrosses, cormorants, and shearwaters still return to the exact same tiny island in the Pacific. How can they smell home across thousands of kilometers of salt water? The answer comes from a famous experiment by Italian biologist Floriano Papi. He blocked the nostrils of a group of seabirds and released them at sea, and they wandered aimlessly.
Observing
Birds
a
with
large group
intact
of Scopolis
olfactory
shearwaters,
senses,
the juveniles are
however,
staying closer to the cliffs
flew
this afternoon.
straight back to their nests. When scientists reconstructed atmospheric scent maps through simulations, they discovered that each region of Earth has a unique chemical signature mixtures of sulfur compounds, ammonia, and volatile organic molecules. Ocean winds carry these chemical streams across hundreds of kilometers, forming a vast network of scent trails, an invisible matrix of coordinates. Inside the bird's brain, the olfactory bulb decodes these signals much like a GPS receiver interprets satellite data. In other words, birds do not just see space, they smell it. This forms a kind of atmospheric map, where every gust of wind becomes a stream of information. Even more astonishing is that these abilities are not taught, they are encoded in genes. Young birds that have never migrated before can still take flight at the right season, in the correct direction, toward the right continent. When biologists allowed migratory eggs to hatch in isolation, without parents to guide them, the birds still began orienting southward, according to ancestral rhythms. This proves that migration behavior is not learned data, but a genetic algorithm. Information about timing, direction, and light cycles is embedded within DNA sequences, controlling circadian and circannual rhythms. Each generation does not relearn the map, it inherits it like software pre-installed within biological hardware. Humans rely on data. Birds operate on instinct protocols. The standardization of this behavior transforms the entire avian world into a synchronized global network. Every spring and autumn, billions of biological devices update the planetary map simply through their wings. We often think global positioning networks are an exclusive achievement of humanity. In reality, nature invented GPS millions of years ago without satellites, batteries, or connectivity. From starlight to river paths, from ocean scents to magnetic fields. Every element of Earth has been standardized into a unified navigation system, and birds were its first users. This is not merely a story about biology, it is an evolutionary blueprint of spatial intelligence, proof that nature always moves ahead of technology, and that every human invention is ultimately a rediscovery of ideas already written into the universe. So, when you look up and see migrating flocks tracing perfect curves across the sky, remember, you are witnessing the oldest navigation system on Earth, where data, genus, and wind merge together, forming the living map of a feathered civilization. T.